In the previous class, we discussed about the canonical quantization of a free scalar field theory, and we have obtained the creation and annihilation operator in terms of the field and the canonical momentum. So I'll just write down what we have obtained in the last class. AK is equal to root of omega k by 2 phi of k plus I omega 1 by 2 omega k phi of k, and A minus k dagger is equal to root of omega k by phi of k minus I root of 1 by 2 omega k pi of k. And we have also obtained the commutator between the fields. Phi of k and phi of k prime is equal to 0. Pi of k prime is also 0, and we have obtained phi of k pi of k prime is equal to I del q k plus k prime. So next we will see the commutation relation between the creation operator and annihilation operator. So first we will take the annihilation operator AK and AK prime. Okay, so here we have the expression for AK. Root of omega k by 2 phi of k plus I by root of 2 omega k pi of k. Okay, this is for AK. Now again AK prime, so I have to change k to k prime. Then root of omega by 2 phi of k prime plus I by root of 2 omega k pi of k prime. Here phi and phi will be 0. The first term, commutator of this will be 0. Then the next will be phi of k with pi of k prime. So that will be plus phi of k and pi of k prime. Then second term with the first term. Pi of k and phi of k prime. Then pi and pi, that will be 0. So the only non-zero terms are the second one and third term. So in the second term, I have to take out I by 2. All the other things will get cancelled because there is root of omega k here. Okay, this root omega and this root omega will get cancelled, and this 2 root 2 will become 2, and there is I. Phi of k phi of k prime plus phi of k phi of k prime. So we have the relation phi comma pi commutator is I del cube k plus k prime. So this will be I by 2. I 2 pi cube I will take outside. Then I have del cube of k plus k prime minus k prime plus k. So here these two terms are also same, which means this will be 0. So we get ak prime commutator is equal to 0. Similarly, next we do ak dagger, ak prime dagger. So here also same thing. I'll get minus I by 2 phi of minus k. Only two terms will survive, all the other terms will be 0 because commutator with the same operator. Phi of minus k prime plus phi of minus k only these two terms will survive, all the other terms will be 0. Minus 1 by 2. So I am taking I outside. So I square will be minus 1. Then 2 pi cube minus k prime minus k prime minus k. So here also 0. So this will be 0. And the most awaited ak prime dagger. Plus I by 2, then minus of phi of k, phi of minus k plus phi of k, phi of minus k prime. So only these two terms will survive, all the other terms will be 0. Then I by 2, I'll take I 2 pi cube common outside, then minus of k minus k prime minus k prime minus k. So I square is minus 1. Then there is a minus that I can take outside from the bracket. So it will be cancelled. 2 pi 2. Then 2 times k minus k prime. So this will be 2 pi cube k minus k prime. So ak dagger prime, ak prime dagger is equal to 2 pi cube del cube of k minus k prime. So you can see that this is a continuum generalization of a dagger equal to 1. Okay, so this is a continuum generalization. So there are more particles involved here, and therefore we conclude that after quantization, this theory have an infinite number of decoupled harmonic oscillators labeled by the continuous parameter k. So k is the continuous parameter here, and there are infinite number of harmonic oscillators that are labeled by this parameter k, and that is being reflected here as k and k prime. Okay, so you can see that this equation is a continuum generalization of the equation a dagger equal to 1, because you have continuous variables present here. And this is because we have already mentioned that the field theory is the continuum limit of particles on the chain. This gives us just the 3D version of a bunch of harmonic oscillators. So next what we are going to see will be that each excitation of the harmonic oscillator can be interpreted as a particle in space-time. So how do you get a particle? Which is more fundamental? Is it a particle or field? So initially people thought that atom was the smallest thing or the indivisible thing in nature. Then people found out that there is a nucleus inside the atom. Then inside the nucleus you have neutrons and protons. Then people said neutrons and protons are made up of quarks. Then comes elementary particles, right? So then field theory says that field is more fundamental, and when you quantize field you get a particle. So each excitation of the harmonic oscillator can be interpreted as a particle in space-time. Okay, the creation operator can be used to excite the vacuum, and we can see that each excitation corresponds to a real particle. So you can have arbitrary number of particles as much as you want, and that's why we see a lot of particle around us. So for corresponding to each particle there will be an excitation. So the creation operator can be used to excite the vacuum, and we can see that each excitation will correspond to a particle. Okay, so these are still commutation relation and they don't tell anything about the harmonic oscillator. So let's calculate the Hamiltonian, the total Hamiltonian, which is the integral of Hamiltonian density, right? So here we have defined the Hamiltonian density as phi dot square by 2 plus half gradient of phi square plus half m square phi square, and phi dot is the canonical momentum pi. So I can replace in the Hamiltonian density and I can write pi square by 2 plus half m square phi square. Okay, so how do I get the total Hamiltonian? I have to take the integral, which means h is equal to, so I can take 1 by 2 common, integral of d cube x phi square plus gradient of phi dot gradient of phi, that will be phi square plus half is already outside, m square phi cap multiplied by phi cap, that is phi square. Now this will be a very tedious calculation, so I'll split it into different integrals. So first I'll calculate integral d cube x pi square. Okay, so integral d cube x pi square means pi of x multiplied by pi of x. So integral d cube x. Now what is pi of x? So we have not defined it here, right? So I'll just write it somewhere again. So we have seen in the last class what is phi and pi. I'll write it once again. Phi of x is 1 by root of 2 omega d cube k by 2 pi cube ak e raised to minus I omega t plus ik dot x plus ak dagger e raised to I omega t minus ik dot x. Okay, this is phi. Now what is pi? Minus I root of omega k by 2 integral d cube k by 2 pi cube ak e raised to minus I omega t plus ik dot x plus ak dagger e raised to I omega t minus ik dot x. So what I have to find is integral of d cube x pi multiplied by pi. So this itself will be a very long calculation. Then I have to find integral d cube x gradient of phi dot gradient of phi. Then I have to find integral d cube x phi dot phi. Then I have to add up everything to get the total Hamiltonian. So let's start the calculation. Okay, so integral d cube x pi of x multiplied by pi of x will be integral d cube x. Now I square will be minus 1 and then still there is a minus. So minus I multiplied by minus I will be minus 1. So minus, now root of omega by 2 times will be omega k by 2 integral d cube k by 2 pi cube, right? Then there is one more integral because pi multiplied by pi. So I am writing the second one, k prime by 2 pi cube. Then first bracket will be, so there is a mistake here, this was minus. Okay, so the first bracket will be ak e raised to minus I omega t plus I k dot x minus ak dagger e raised to I omega t minus I k dot x. Okay, then there will be one more bracket from the second pi, that will be ak prime e raised to minus I omega t plus I k prime dot x minus ak prime dagger e raised to I omega t minus I k prime dot x. Now this minus omega k by 2 is a constant, so I can take it outside the integral. Minus omega k by 2 integral d cube x. Then there are two integral d cube k by 2 pi cube integral d cube k prime by 2 pi cube. Then I have to multiply these brackets. So first term in the first bracket multiplied by the first term in the second bracket, and you have to open the bracket. So next term will be first term in the first bracket multiplied by the second term in the second bracket, and similarly you have to do for the other terms also. Okay, so that will be ak prime e raised to minus 2 I omega t plus I k plus k prime dot x minus ak prime dagger e raised to I k minus k prime dot x minus ak dagger ak prime then e raised to minus k minus k prime dot x plus ak dagger ak prime dagger e raised to 2I omega t minus k plus k prime dot x. So there are 4 terms. Okay, now I can see there is a e raised to term here. Okay, so integral d cube x e power something will be Dirac delta. So we have the standard. So what I do, first I do integration with respect to d cube x. Okay, these two integrals will wait. I am taking d cube x inside. That will be minus omega k by 2. So let other integrals wait. First I'll integrate with respect to x. Okay, so first term will be ak prime as it is. Now in e raised to minus 2I omega kt is a constant. So I have to integrate d cube x e raised to I k prime k plus k prime dot x. So this is what I have to integrate in the first term. Okay, so this will give 2 pi cube delta k plus k prime. So that is this integral. Okay, so I am just replacing this integral with this one. Okay, now I have to integrate the second term minus ak prime dagger. Now integral of e raised to I k minus k prime will be 2 pi cube k minus k prime. Next term ak dagger ak prime 2 pi cube k minus k prime minus k plus ak dagger ak prime dagger e raised to 2I omega t 2 pi cube minus k prime. So here there is a 2 pi cube which I can cancel everywhere, right? Now it's easy. Minus omega k by 2 integral d cube k by 2 pi cube. Now next integration I will do with respect to d cube k prime. Okay, so I will take d cube k and I'll integrate. In each term I think the only variable that is present in k is the Dirac delta. So I just have to integrate the Dirac delta. Okay. Then I'll get ak. What is the first integral? K plus del cube of k plus k prime. Okay, so this will be 1 only if k is equal to minus k prime. So while I integrate, I have to take k is equal to minus k prime. Therefore AK, otherwise K prime is equal to minus K. So here instead of K prime I can write minus K. So AK, A minus K e raised to minus 2I omega kt minus AK and what is the second term here? K equal to K prime, right? Here K equal to K prime in here. Therefore I can write AK dagger because K prime is K. Similarly in the next term also K prime is K. So AK dagger AK plus AK dagger A minus K dagger e raised to 2I omega kt. Okay, so this is just the first term of our Hamiltonian. Okay, so we have done only the first term, integration of the first term. Now I have to do the integration of the second term. Integral d cube x phi of x. So this will be, again I have to substitute. Now here I can do one thing, I can replace this gradient with the wave vector k, because the gradient and the wave vector both gives you the direction. Okay, so integral d cube x 1 by 2 omega k integral d cube k by 2 pi cube d cube k prime by 2 pi cube. Then here you have k and here you have k prime. So I can write k dot k prime. Then the corresponding operators in phi. So AK e raised to minus I omega t plus I k dot x plus AK dagger e raised to I omega t minus I k dot x. First one, and now the second phi, right? Second phi will be AK prime e raised to minus I omega t plus I k prime dot x plus AK prime dagger e raised to I omega t minus I k prime dot x. Now I have to multiply each term. First AK with the first term in the next bracket, then first term in the first bracket with the second term in the second bracket. Likewise you will get 4 terms again, which is equal to 1 by 2 omega k integral d cube x integral d cube k by 2 pi cube k prime by 2 pi cube. Then k dot k prime I can write mod k square, right? Okay, so for time being I'll keep it as k dot k prime, others will get confused. Okay, so when you introduce the Dirac delta, then k will be either plus or minus k prime. So at that time I will take the modulus. Okay, so till that let it be k dot k prime, otherwise you will get confused. ak prime e raised to minus 2I omega t e raised to I k plus k prime dot x plus ak prime dagger e raised to minus k prime dot x plus ak dagger ak prime e raised to I k prime minus k dot x. One more term plus ak dagger ak prime dagger e raised to 2I omega t e raised to minus I k plus k prime dot x. So the method is same as what we did in the last terms. First I will integrate with respect to d cube x. 1 by 2 omega k integral d cube k prime ak prime e raised to minus 2I omega t, then 2 pi cube Dirac delta k plus k prime plus ak prime dagger 2 pi cube k minus k prime plus ak dagger ak prime e raised to, sorry, here there will not be any e raised to term, it will cancel. Only the first and the last term will only have the exponential terms. So ak dagger ak prime 2 pi cube k minus k prime. And the last term ak dagger k prime dagger e raised to 2I omega t k plus k prime. So in all the terms you have either Dirac delta of k plus k prime or k minus k prime. If it is k plus k prime, then k must be minus k prime. If it is k minus k prime, then k will be equal to k prime. So in general I can write k is equal to plus or minus k prime. So in that way, if k dot k prime will be k dot plus or minus k, right? So k dot k will be mod k square. Okay, so in the next step I will write k dot k prime as mod k square, and I will also integrate with respect to d cube k prime, so that all the Dirac delta will be equal to 1. So here I can cancel all the 2 pi cube. Now I integrate with respect to d cube k. So this will be 1 by 2 omega k integral d cube k by 2 pi cube mod k square ak a minus k e raised to minus 2I omega kt plus ak dagger plus ak dagger ak plus a k dagger a minus k dagger e raised to 2I omega t. Okay, so this is the second term of the Hamiltonian. Where is my Hamiltonian? Yeah, so second term of the Hamiltonian also we have integrated. Now I have to integrate the third term. Then I have to add up all these terms to get the total Hamiltonian. So the last term in the Hamiltonian integral d cube x. There is m square phi square, so m square I can take outside, or otherwise m square I can multiply in the last step while I am adding it up. For the time being I will do phi of x, phi of x. This will be 1 by 2 omega k integral d cube k by 2 pi cube d cube k prime by 2 pi cube ak e raised to minus I omega t plus I k dot x plus ak dagger e raised to I omega k t minus I k dot x and ak prime e raised to minus I omega t plus ak prime I omega t minus, okay, so again I have to expand the bracket. I have to multiply the first term of the first bracket with the first term of the second bracket and so on. Integral d cube x 1 by 2 omega k integral d cube k by 2 pi cube k prime by 2 pi cube ak prime e raised to minus 2I omega t e raised to k plus k prime dot x plus ak prime dagger e raised to I k minus k prime dot x plus ak dagger ak e raised to minus I k minus k prime dot x plus the last term ak dagger ak prime dagger e raised to 2I omega t e raised to minus I k plus k prime dot x. So I will follow the same steps. I am not repeating all the steps because first I will integrate with respect to d cube x, then I will get Dirac delta. Again I will integrate the Dirac delta with respect to d cube k prime and all the 2 pi cubes will get cancelled. Okay, so I will write the final equation. So this will be equal to 1 by 2 omega k integral d cube k by 2 pi cube ak prime or a minus k I can write e raised to minus 2I omega t plus ak dagger plus ak dagger ak plus ak dagger a minus k dagger e raised to 2I omega t. Okay. Now the total Hamiltonian will be summation of all the terms. So I'll just give the last expression. You can just add everything up and you will get 1 by 2 integral d cube k by 2 pi cube minus omega k by 2 ak. Either I can write in terms of minus k, or I can write k prime is equal to minus k. That's what we have taken. So instead of minus k, I can write k prime also. So both are right. So for convenience, I'll just write k prime. E raised to minus 2 I omega t minus ak dagger minus ak dagger ak plus ak dagger ak prime dagger e raised to 2I omega t. Okay, plus m square plus mod k square by 2 omega k. So this k square came from the second term and this m square came from the last term. So I'm just writing because some of the coefficients are the same, so I'm taking it outside and writing it as common. And there is a 1 by 2 omega k also, which is common. ak prime e raised to minus 2I omega t plus ak dagger ak plus ak dagger ak prime dagger e raised to 2I omega kt. So this is the total Hamiltonian. So I can still do some cancellation somewhere. Let me see. See, here you have ak dagger, ak, and here you have minus ak dagger. So I can take the common outside. Okay, so I can again rewrite and simplify this equation as 1 by 4 because I can take 1 by 2 from here and 1 by 2 from here, and already there is a 1 by 2 that is outside, so that it will be 1 by 4. 1 by 4 integral of d cube k by 2 pi cube m square plus k square minus omega k square by omega k. Okay, I have just taken out some common. Then I'll get ak prime e raised to minus 2I omega t plus ak dagger ak prime dagger e raised to 2I omega t, and m square plus k square plus omega k square by omega k multiplied by ak dagger plus ak dagger ak. But we have already seen that e square is equal to m square plus k square, which is equal to omega k square, right? Because e is equal to h cross omega, h cross is 1. So e square is equal to omega k square. But see, here you have a term m square plus k square minus omega k square. But m square plus k square is omega k square. Therefore, that entire term will be 0. Okay, so this entire term will be 0. Therefore, I have 1 by 4 integral of d cube k by 2 pi cube, and only the second terms will survive. That is, these terms will only survive. d cube k by 2 pi cube, I have 2 omega k square. And similarly here I can substitute m square plus k square as omega square. So omega k square plus omega k square will be 2 omega k square. So 2 omega k square by omega k. Second bracket will be as it is, ak dagger plus ak dagger ak. So therefore I can write, so this 2 and 4 will cancel, will get 2 omega, so I'll get 1 by 2 integral d cube k by 2 pi cube omega k multiplied by ak dagger plus ak dagger ak. So this is the total Hamiltonian H. Okay. So for today we'll stop here. Tomorrow we will analyze this, what are the implications of this equation,